Welcome, everyone. We are the team working on PoetAI project. We are mentored by Professor Rita Singh, and we are Bandish, Lokeshwar, Sandeep, and me, Ashish. To set the agenda straight, we'll be discussing a little bit about the story and then these things, so forth. Well, the story to be put into perspective, Professor Rita Singh asked us a simple question. Will we be interested in publishing the next version of this book for you humans? The problem being, how do we measure rhyming? How do we measure context? And is it even possible? If possible, what is the ramification of this finding? Well, we think aided art is something that is set for us in the future. Once we drill down onto what we're trying to solve, the idea was specifically called in the literature is called automated limerick generation. What is a limerick? Well, a limerick is a poem that consists of 5 lines in a single stanza with a rhyme scheme of AA, BB, and A. In the generation sense, we will be using a machine learning model, which is taught open source limericks to generate limericks with or without prompt. Looking at some previous work, we see work by the CMU's AABBA team to be the best so far. They've used OpenAI's GPT-2, specifically the 117 million parameter model. They trained it on 90,000 limericks used by PoetRNN. Their evaluating metrics were rhyming distances and coherent metrics, which they used to filter the generations from the GPT-2 model, where they found out that they were able to isolate 13.1% of the limericks successfully. Let's look at our journey so far. We were able to reproduce their work on TensorFlow, but we moved all of that to PyTorch, specifically the latest version of it. We also find literature that supports moving from 117 to 345 parameter model for poetry. We then added 2 different losses to the existing cross entropy loss, the context loss and the rhyme loss, as we call them. And then we decreased the training time 4x by minimizing the length of the tokens to be predicted. This is a simple comparison of how 345M model outperforms the 117M model in terms of perplexity and accuracy, respectively. The dataset that we in question is the same dataset used by the PoetRNN team. We, though, cleaned it out of any profane limericks and logging errors. Certainly, you can see a simple sample here. We put in limericks into the GPT-2 model to create new limericks, also to say predict the next limerick possible. This would give us a cross entropy loss that the GPT-2 model suggests, and we add context loss and rhyme loss that we'll talk about in the next few slides. We aggregate all of that loss together to create a total loss, which is backpropagated to the GPT-2 model. Let's talk about the context loss. In the context loss, we basically take embeddings for each of the lines that is predicted by the GPT-2 model. We push it through a self-attention LSTM, which gives us contextual vectors for each of these lines. We calculate the MSE distance between each of these contextual vectors and try to minimize that. Let's talk about rhyming loss now. Rhyming loss, we specifically see that the first 2 lines and the last lines have the same rhyme. We try to create phonemes of these specific words and the words and the other rhyme scheme words as well, and try to calculate the Levenshtein distance of all of these pairs. Well, the story so far has been that we've been able to aggregate all these 3 losses and pass it back successfully to the GPT-2 model. This is the training trajectory that our model has taken. And these are the results. As you can see, by adding just the context loss, there is a better understanding of who the person is and how it's being referred to across the poem as compared to just the default generated limerick. When we put only the rhyme loss through, we see rhyme has started to be maintained rather than not. Putting all of these together, we can see it does a much better job than just when the context loss is applied to when the rhyme loss and the context loss is together applied, where we see the rhyme and the context pretty much well done. Feel free to pause and check. Concluding this session, our learnings have been that the GPT-2 model is incapable of learning rhymes on its own. We have to feed it a loss somehow. We've also learned that we can actually build a loss aggregator around the whole idea. We have also made the limerick generation process more efficient and faster. The code base is now much more accessible because of the technical debt being removed. We see a way forward where the quality metric, as in the metric of measuring art itself, can be explored. We also see GANs being applied to the problem of creating these automated limericks. I hope this was a great session for you. See you in the next one.